Here we can use our understanding of aromaticity to predict the relative reactivity of two compounds. So in this case we have two organobromides, and the question asks which of the following will react faster in an SN1 solvolysis reaction. So remember, that is carbocation formation. So that's our rate determining step. That's what we want to think about here, is if we lose the leaving group Br from the molecule, what do we get? We get this carbocation. And likewise in the second molecule, very similar. So what we want to think about here is how the process is favored or not favored. And that all comes down to knowing that something that is aromatic is the most stable, then non-aromatic, and then anti-aromatic would be the least stable. So up here, things are happy. Down here, things aren't as happy. So in terms of a reaction or a reaction step, if we can go from something less stable to something more stable, that's going to be favored. But if we go from something more stable down to something less stable, that's not going to be a favored process. So let's compare these two. In the first case, we have this just 7-membered ring with a Br. It's not a conjugated system. We have a non-aromatic starting material. And after the reaction, we have a non-aromatic product. So essentially, nothing gained, nothing lost. You're not really getting less stable in terms of aromaticity. You're not getting more stable. Next, if we look at the second one, we start with the compound that isn't completely conjugated because there's no p orbital right here where the Br is attached. Because of that, this is non-aromatic. But then once we get the product of this reaction step, we end up with these 6 pi electrons, and thanks to the carbocation, we now have a conjugated system. Because of that, this is now an aromatic compound. So what we've done here is we've gone from something non-aromatic up to something aromatic. We're going from something less stable to more stable. That is a favored step. That means the second reaction is going to be a faster SN1.